So this is night 5.3, identifying forces. We've already had two very conceptual sections on forces. Knight's trying to help you avoid making a lot of mistakes. He's breaking it down piece by piece. So we've had terminology and the fact that forces are vectors in 5.1. In 5.2, we've had a catalog of forces and how to add up forces to make a force total. And now we're in 5.3, which is identifying forces. Now this reason identifying forces is tricky is because there's a lot of different sort of agents and objects, to use the language of 5.1. So here's Dad pulling on a rope, which is pulling on a sled, which is got a kid on it. There's a lot of different things. There's at least 1, 2, 3, 4, including the ground. There's 5 different things in this picture. So what we do when we're identifying forces is we isolate one thing. So for example, suppose I was to isolate the child. So here, there's the child sitting on the sled. Now that we've got the child isolated, we can go, oh, there's a force of gravity on the child. And because the surface of this sled is pushing up on the child's legs, there's a normal force. And that might be about it. And I'll make it a little bit more complicated. Suppose Mom here is pulling so hard that the sled's actually speeding up. Well, I'll tell you what happens then. First of all, there's going to be a lot of things happening, like this tension in this rope is going to be higher, and the sled's going to be accelerating, and all sorts of things are going to be happening. But the key thing that's happening when you're looking at the picture of the child here is that in addition to a normal force of the sled on the child's legs, there is now also a horizontal force of the sled on the child's legs. And it's actually, if the sled's speeding up, it's forward. And as long as the child isn't slipping backwards on the sled, then this is a static friction, okay? And so we go F sub static, we write it like that. And F sub static is in the forward direction. You can be a bit sloppy with these. Where I put the tails of the vectors wasn't super precise. Knight may actually have a strong opinion about where exactly he wants the tails of the vectors. We're going to get much more precise when we finally get to 5.7, which is called free body diagrams. Then I will want you to be precise too. The way we model things at this point in the course, the child, even though the child is this big extended thing with a head and arms and legs, at this point in the course we're modeling objects as particles. And when we do a free body diagram of a particle, what we do is we take all the forces that we'd identified in this identifying forces part of the problem solving, and we put their tails on this point, so that we copy over, for example, we take F sub g and we copy it over right there. And we take the normal force and we copy it over right there. And, ooh, bad. And we take the static force and we copy it over right there. That's the way Knight and I want your free body diagram for the child to look. Okay, that's 5.3.